Sam, what are you doing?
Hi. I want to finish my homework before midterm break, so I want to feel free during my holiday and not any interrupt.
This is look like a mathematics.
It's actually a mathematics, but this mathematics using in arithmetic logic unit, or we usually call it as an ALU.
What is ALU?
Let me explain, Bob.
An arithmetic logic unit, or ALU, is a part of the central processing unit, or CPU, that carry out arithmetic and logic operation. In computer science, ALU serves as a conventional digital circuit that performs arithmetic and bitwise operation on binary number. The following are the few examples of bitwise logical operation and basic arithmetic operations supported by ALU, such as addition, subtraction, and more. But in this course that we have taken, we just learned how to do the numeric conversion in number bases like decimal number, binary number, octal, and hexadecimal.
In computer science, of course, we never run from the topic ALU, but this course, the name chapter is number system. So, in this chapter, we will gonna learn a binary representation. The second is bit, byte, and words, number bases, numeric conversion, addition and subtraction, signs and magnitude, first and second complement conversion, and last but not least is IEF 14-point representation. But today, we will gonna learn in addition for the arithmetic logic unit. So we are going to the next question, which is 245 in octal number plus 1010011 in binary number. So the answer is we want to prove the answer in a binary number. So what we're gonna do first is we want to convert this octal number into a binary number. So let's rewrite this number again. So 245 number bases in A. So how do we want to calculate this? So we want to put the number starting by 0, 1, and 2. Why we gonna do this? Because we want to multiple all this number multiplied by A. So open bracket 2 multiple A powered by 2 close bracket 8 4 multiplied by A powered by 1 8 5 multiplied by 8 power 0. So after we done make this calculation, so we are going to calculate all this in the bracket to get the answer. So 2 multiplied by 8 powered by 2, we got 128 plus 4 multiplied by 8 power 1, we got 32 plus 5 multiplied by 8 power 0, we got 5. So after we get all the answer, so we want to add all the answer. So we got 165. So are we finished yet for this calculation? Not exactly, because this final answer is in decimal number. So how we convert this answer into the binary number? So we are going to divide by 2 for this answer. So 2 divided by 165. So 165 divided by 2, we got 82. So let's recheck. So this answer, if it has a value for the answer, so it has, we put 1 inside of the answer. So let's calculate again. So 82 divided by 2, and we got 41. Sorry. So let's reject this answer. So this answer has no balance on it. So we're gonna put 0 inside of this answer. So this calculation will continue and continue again until we got 0. So we are finally get all the answer until the final answer is 0. So how we want to read this number as a binary number? So we study from the bottom straight up into the top answer. So we will got 101001 binary number. So we finally got the binary number for this octal number 245 in octal number into 10100101. So after we get this binary number, so we finally start this calculation. 10100101 plus 1010011. So let's start our calculation. So 1 plus 1 equals to 10. So why we put 10 over 2? Because in binary number, the computer accept the 1 and 0 digit only. So we're gonna put 0 and 1 top of this next calculation. So 1 plus 0 plus 1, we got again 1 0. So 0 1. So 1 plus 1 plus 0. So we got still get the same answer. So 0 put the bottom on the equation and put 1 the top on the next equation. So we will get 1. So we finally get the final answer, which is 11111000 in binary number. So the final answer will 11111000. So we are finally finished this question successfully. So we are going to the next question, which is 245 in octal number plus 10110110 in a binary number. So the answer is, we want to prove the answer in an octal number. So let's start it. So the first, we must convert this octal number to a binary. So this number, we finally convert it to the binary number in a binary equation. So 245 that's 8. So we got 1011 011 0, 1, 1, 0. So after we get this binary number, so we can finally calculate this one. So 1, 0, 1, 1, 0, 1, 1, 0, 2, plus 0 plus 0 equal to 0, 1 plus 1 equal to 1, 0, 1 plus 1 plus 1 equal to 1, 1, 1 plus 0 plus 0 equal to 1, 1 plus 1 equal to 1, 0, 1 plus 1 plus 1 equal to 1, 1. So 1 plus 0 plus 0 equal to 1, and lastly 1 plus 1 equal to 1, 0. So is this the last answer for this equation? Not, because the answer is we must to convert it into an octal number. So we must rewrite plus so from each odd number we must put the digits starting from 0, 1, 2, 3, 4, 5, 6, 7, and 8. So from each odd number we must to multiply by 2. So it will gonna be like 1 multiplied by 2 over 8 plus 1 multiplied 2 over 6 plus 1 multiplied 2 over 5 plus 1 multiplied 2 over 3 and last 1 multiplied 2 over 2. So after we make this equation, so we want to find the answer of this in the bracket first. So 1 multiplied 2 over 8, we got 259. And next we got 64. Next we got 32. And then next we get 8. And last we get 4. So calculate all these answers and we get 364. But this final answer are in a decimal one. So if we want to convert into an octal number, so we must do divide by 8. So 364 divided by 8 and we get 45. In radian 4. So 45 divided by 8 equals to 5. Radian by 5. And last but not least, 5 divided by 8 equal to 0. So how we want to get the octal number is we start from the bottom straight up to the top. So lastly we got 5, 5, 4 versus 8. So this is actually answer for this equation. So for the next equation is 274 in an octal number plus 11110 in a binary number. So the answer is, we want to prove the answer in hexadecimal number. So let's split into 2. So we want to convert for this number first. So 274 versus 8. So what we're going to do is to multiply 8 over 2 plus 7 multiply 8 over 1 plus 4 multiply 8 over 0. So solve of this in the bracket equation. So what we got for the first equation is 128 plus 56 plus 4. After we get all the answer of each equation in this bracket, so we must calculate all the answer and we will get 118 by in decimal. So for the convert to the convert to the hexadecimal, we must divide by 16. So 188 divided by 16, and we will get 11 redundant by 12. But in hexadecimal, 12 will convert to the C. Alright? And we will go to continue to the next calculation. 11 divided by 16 equals to 0. So we get 11 as a B. So done for this conversation for this number. So let's move to the binary number. So 1, 0, that's 2. So 1 plus 2 over 4 plus 1 multiply 2 over 3 plus 1 multiply 2 over 2 and 1 multiply 2 over 1. So all of this equation in this bracket, so we will get 16 plus 8 plus 4 and plus 2. So calculate all the final answer 8 and we will get 30. So now we want to divide by 16. So 13 divided by 16 equal to 1. Redundant by 14, or in hexadecimal is E. So next 1 divided by 15 equal to 0. So we got redundant 1. So we finally get So we finally get all this number into a hexadecimal conversion. So what we're gonna do is we want to calculate both of these numbers. So BC plus 1E. So let's start for this equation first. So C equal to 12 plus E 14. So we will get 26. In hexadecimal, the maximum of the number is 16. So how we're gonna do this is we want to subtract to the 16. So we will get 10 or 8. So we put 8 as the answer, and after this we want to put 1 the top of the next equation. So the next is B 11 plus 1. So we will get 12 equal to C plus again 1, and we will got 30, which is D. So we finally get the answer in hexadecimal. So 274 versus 8 plus 11110 versus 2. So we get D A as a final answer.
In this case study, we gain more knowledge about in-topic numeric composition such as decimal, binary, octal, and hexadecimal. In ALU, there's a lot of arithmetic logic operations such as addition and subtraction. For the conclusion, ALU or arithmetic logical unit are more important in computer system. So, without ALU, the whole computer system are not working successfully. So that's all from me. Thank you and see you later.